You are right to be frustrated. You have spent hours building pipelines only to watch them break because the model returned data that looked perfect but was structurally wrong. This is not a bug in your code. It is a fundamental architectural mismatch between how these models think and how your database needs data. By the end of this video, you will understand exactly why treating an LLM as a validator is a recipe for disaster. And more importantly, you will learn the specific pattern that allows you to use them safely in production without corrupting your data. Let us start by understanding the core conflict. You are trying to force a probabilistic engine to perform a deterministic task. An LLM does not read data like a database does. It does not check types, enforce lengths, or validate foreign keys. It predicts the next token in a sequence based on statistical likelihood. When you ask an LLM to validate a schema, you are asking it to guess what the correct structure should look like rather than checking if the structure matches a strict rule. This is the root of the failure. The model optimizes for semantic plausibility, not logical consistency. It will happily generate a JSON object that looks like valid data but violates your hard constraints because the words around it feel right. Consider the fragility of these models. Research into LLM hacking has quantified this risk with startling precision. Studies show that 1/3 of hypotheses yield incorrect conclusions simply due to minor variations in the prompt. Even more disturbing, changing a single variable name or adding a space can alter prediction errors by as much as 82%. This means your validation logic is not stable. A prompt that works perfectly on Monday might fail on Tuesday if the underlying model updates or if the context window shifts slightly. This is catastrophic fragility. It is a system that works until it does not, and when it fails, it often fails silently. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. This leads to a dangerous phenomenon known as hallucinated validity. The model will confidently assert that malformed data is correct because the surrounding text suggests it should be. It creates a false sense of security. You see a string of text that appears to follow your rules, so you accept it. But underneath, the logical structure is broken. This is not a simple typo. It is a systematic bias introduced by the model's attempt to be helpful rather than precise. The model wants to complete the pattern, not enforce the boundary. When you treat it as a black box annotator, you are introducing a source of error that is nearly impossible to debug because the error itself looks correct. Now consider the implications for your data pipelines. If you rely on an LLM to filter or validate incoming data, you are building a system on top of a probabilistic foundation. Any downstream process that assumes data quality will inherit this instability. You might think you are using the model to clean data, but you are actually introducing a new class of bugs that are hard to trace. The model might pass a record through because it looks similar to training data, even though it violates a business rule. This creates a silent corruption that can propagate through your entire system. The cost of this is not just a failed job. It is the loss of trust in your entire data infrastructure. So, if we cannot use LLMs for validation, how do we use them at all? The answer lies in reframing the role of the model entirely. We must stop thinking of the LLM as a gatekeeper and start thinking of it as a generator. The viable production pattern is not LLM as validator, it is LLM as reviewer within a generate-validate self-correct loop. In this workflow, the LLM proposes data transformations or content, but it never decides the final outcome. The proposal is then subjected to strict, deterministic, rule-based validation before any execution occurs. This approach leverages the generative flexibility of the model while enforcing the reliability of traditional code. The LLM acts as a creative engine, suggesting how to parse messy input or transform complex records. But the actual validation is handled by a deterministic engine like Great Expectations or a SQL query. These tools do not guess, they check. They verify types, lengths, and logical constraints with mathematical certainty. If the LLM's proposal fails the check, the system rejects it immediately. The model does not get to argue its way out of a failed constraint. The magic happens in the self-correction loop. When the deterministic validator rejects a proposal, the LLM receives the error message as feedback. It can then attempt to correct its own output based on that specific failure. This creates a hybrid system where the model learns from its mistakes in real time. However, there is a catch. The research suggests that the threshold for self-correction is not infinite. Even with this loop, you still need human-in-the-loop oversight for edge cases. The model can fix common errors, but it cannot guarantee near-zero error rates in complex, high-volume pipelines without some level of supervision. The key insight here is that the LLM is no longer the authority. It is a draft generator. The authority is the deterministic code. This shifts the risk profile dramatically. Instead of hoping the model gets it right, you know exactly where the failure points are. You know the rules, and you know the model is just a tool to help you apply them. This is the only viable production strategy until models demonstrate robustness against task-irrelevant variations. Until then, the generate-validate self-correct loop remains the bridge between generative power and data integrity. You might wonder if this adds too much complexity. It does add a step, but it removes the risk of silent failure. The time you spend building the validation layer is an investment in stability. It is the difference between a pipeline that works sometimes and a pipeline that works every time. The LLM handles the heavy lifting of interpretation, and the code handles the heavy lifting of verification. This division of labor respects the strengths of each technology. In the end, the frustration you feel is valid because you were trying to solve a deterministic problem with a probabilistic tool. The solution is not to wait for the models to become perfect validators. The solution is to change how you architect your systems. Use the model for what it is good at, and use code for what it is good at. That is how you build systems that are both intelligent and reliable. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.